Question number 9. A moving average function is given by y of t is equal to 1 by t integral t minus t to t u of tau d tau. If the input is a sinusoidal signal of frequency 1 by 2t Hz, then in steady state the output y will lag u by dash. So we are looking for the angle here in this question, and it's not a multiple choice, so let's see how we can work it out. Now the question tells us that the function is given y of t is equal to 1 by t integral t minus t to t u of tau d tau. Now u is given as the sinusoidal signal. It's a sinusoidal signal, so let's assume and write it as sine of omega tau. Okay, sine of omega tau. Since it's a sine wave, let's take it as omega, some omega tau, where omega is the angular frequency and we know the formula 2 pi f. Now the frequency is given as 1 by 2t. So let's substitute that. Omega is equal to 2 pi into 1 by 2t. That gives us pi by t. So if omega is equal to pi by t, omega into t is equal to pi. So just remember this relation. We will use this relation in a step later. Omega t is equal to pi. Okay, so now let's substitute sine omega tau in place of u of tau. So y of t would equal to 1 by t integral t minus t to t sine of omega tau d tau. Okay, so this is our expression now. If we integrate sine of omega t, omega tau, let's write that down. We are going to integrate this. So we now get y of t is equal to 1 by t. So it's integral of sine omega tau, which would give us minus cos omega tau divided by omega from t minus t to t. Now since we have a negative over here, a negative symbol, let's flip the limits over so that we can evaluate the expression for a positive term. So this term becomes positive when we write it as cos omega tau by omega from t to t minus t. So I flipped the limits over and eliminated the negative sign. Now we'll take omega outside, 1 by omega t cos of omega tau from t to t minus t. Let's substitute and see what we get. Y of t is equal to 1 by, now in the previous step we found out the expression for omega t is equal to pi. So let's substitute 1 by pi into, now cos of omega tau, that would be cos of omega t minus t minus cos omega t. Now here we have, let's look at this as cos of a minus cos of b. Now you know you'll have to recall the trigonometric identities and sum as products formula so that we can convert cos of a minus cos of b and simplify it as much as possible. And when we do that, we get 1 by pi into minus cos omega t. This entire thing can be resolved as 1 by pi minus 2 cos omega t. So this gives us minus 2 by pi cos omega t. Now if we write this in terms of sine, in terms of the input signal, minus 2 by pi cos omega t can also be written as minus sine of 90 plus omega t. Sine of 90 plus theta is cos. Minus sine of 90 plus theta is cos theta. So here this becomes a positive expression, 2 by pi sine of 90 plus omega t or theta. Now if we are to compare the output waveform here, y of t is 2 by pi sine of 90 plus omega t. Our input is u of tau or u of t, which is sine omega t. Now we have input sine omega t, output sine of 90 plus omega t, which means that it lags by 90 degrees. So the answer here is 90 degrees. Answer is 90. Well, I hope this explanation is clear.